right? In this class, we are going to study about Unit 5. In Unit 5, I'm going to give you some introduction, and after that, overall introduction to Unit 5. After that, introduction to 555 timer and its features and application of 555 timer and functional diagram of 555 timer. So all these we are going to learn and understand. Any problem? Someone is making noise, right? Okay. In Unit 5, if we observe, you see introduction to 555 timer. Introduction to 555 timer as a first topic. Okay, introduction to 555 timer. Then functional diagram of 555 timer and monostable and stable operations. So what is this 555 timer? Why we are learning this in this unit? Okay. So the title of our subject is linear ICs and applications, LICA, right? LICA. So many linear ICs we are learning. That means restricted to our syllabus. So many linear ICs are there in the world, but according to our syllabus, some few linear ICs, otherwise we say few analog ICs are included in our syllabus, and these we are going to study, right? So till now we have studied about a linear IC 741, right? So IC 741, we have dedicated so many units. Okay, Unit 1, what is the internal diagram of IC 741? That means the differential amplifiers we have studied in Unit 1. One complete unit is dedicated for differential amplifiers which are used in designing op-amp. Okay. In Unit 2, we have studied about the performance characteristics, otherwise the parameters that describe the performance of the op-amp 741 we have studied. In Unit 3, we have studied various linear and non-linear applications of op-amp, right? That means there we have studied summing amplifier, inverting summing, non-inverting summing amplifier, then subtractor, then difference amplifier, right? And after that, integrator, differentiator, then comparator, inverting comparator, non-inverting comparator, comparator, a positive reference voltage, comparator with the negative reference voltage, then regenerative comparator, which is nothing but a Smith trigger, then a stable multi-application, monostable vibrator, that is like a square wave generator, and that means all these are the applications of 741 IC, right? Then triangular wave generator. So like that we have studied various sample and hold circuit, and after that in Unit 4 we have studied about the filters, active filters. Okay, so all these active filters again, a low pass filter, high pass filter, band pass filter, and band reject filter, first order filter, second order filter, third order, fourth order, fifth order, any higher order filter we can design, right? So these many applications we have seen, all these are with a linear IC or an analog IC, which is an IC 741. After that, we have seen some analog multiplier IC, that is AD533, and then 533 and 534, and then a balanced modulator IC 1496 or 1496B, like that. Okay, so these are some analog ICs we have studied, and few more linear ICs we are going to study in Unit 5 and in Unit 6. Okay, so now today we are learning about Unit 5. So in Unit 5, what we are going to study is, we are going to study about a 555 timer IC. This is another IC which is also named as timer. So how 741 op-amp, like that we say this 555 timer IC, right? So 555 timer we say, that means IC 555, and 556, that means if we study about 555, two 555 ICs combined, we say it is designed, it is named as 556. Okay, two 555 timers are used in 556. Okay, so in unit 5, we are going to study about 555 timer IC, and then if you observe functional diagram, monostable and stable operations of this 555 timer, and then the Smith trigger, then after that you see phase locked loop. Okay, so for this phase locked loop, what is the basic concept of phase locked loop? The block schematic, introduction, and a principle and description of individual blocks we study, and after that this PLL is available as an IC, and it is named as 565, right? So this 565 IC also we are going to study. You just observe 555 timer. Two such 555 timers are included. Another timer which is a 556 IC, and after that phase locked loop it is 565 IC, right? Phase locked loop IC, which is a 565 IC. Phase locked loop PLL applications. Then what are the various applications of PLL IC, that is 565 IC or PLL phase locked loop? It is frequency for frequency multiplication, and for frequency translation, for amplitude modulation, frequency modulation, and FSK demodulators. Okay, AM, FM, and FSK demodulators. Okay, then after that, applications of voltage controlled oscillator. You observe this is another IC, right? So this is 565. This is 566. Okay, and this is 555, 555. It is 556. Okay, just next version here. Just next version. Okay, so like that. Here in this unit, we are going to learn about completely. We are going to learn completely about 555 timer and its functional diagram, its applications, its other. Other applications, operation of this IC, all that, and how it is available. Okay, that means in what are the different package types it is that. Okay, for 741, we know it is an 8-pin IC. It is also available as what is that, 14-pin IC. It is available in a dual inline package and also metal can package. And internal diagram we know, the block diagram we know for 741. Similarly, we are going to learn about all these ICs, right? So 741, it is a versatile IC. It has so many applications. Therefore, we have studied all these applications as a complete unit. I think even filters is application of this 741 as complete unit. Okay, so this 555 timer we are going to study here. So with this brief introduction to unit 5, right? Brief introduction to unit 5. Let us move forward to the first topic, that is introduction to 555 timer, right? So I think I have mentioned what all we are going to study. In brief, we say we are going to study about just two ICs, 555 and 565. So what is 556? It is two such 555 timers are cascaded, and with the modification we can say 565 is PLL and 566 is another IC. Otherwise we say we are going to study about 4 different ICs in this, 4 different analog ICs in this unit 5. Okay, now let us see what is a 555 timer. That means what are the features of this 555 timer, right? So this 555 timer IC, okay, this 555 timer IC, it is one of the most popular IC, right? So one of the most popular, one of the most popular IC, and it is a versatile IC. So what do you mean by versatile IC? It is having so many applications. The IC which is having so many applications, which can be used for many applications. then we say versatile, which can be used for many applications. So 555 timer is also a versatile integrated circuit or versatile IC, right? And it is one of the most popular IC. And you will wonder, it was, I mean, 30 years back, because when I have studied my diploma, that means less than your age, I think. You are in third year, no? So, yes, at your age, when I was at your age, I have studied this 555 timer. One essay question we got in exams, okay, year wise those days. So year-end exams, we got one essay question on 555 timer, and not only that, I have designed some circuits. Okay, it is like traffic lights, traffic light controller. We have designed, and then what is that? A harmonium, right? A simple harmonium, sari gama, like that. Okay, that also I have designed. Then 16 tune doorbell. Those days we do not know, we were very small. So doorbell giving sound, speaker giving sound, it was a little bit thrilling. And 16-bit, 16 music doorbell, 16 different musics we used to get. Okay, so 30 years back, I have designed all these circuits as mini project, or in BTech, of course, as a mini project, and in diploma also as mini project, and one circuit as hobby circuit. Like that, I have designed just a few decades back using this 555 timer. That means you can see how many you can imagine how many applications this 555 timer is having. And if you observe this second point, it is around 30 years old, and it is still being used, right? It is still being used. And the first this 555 timer IC was first introduced by this Cynetics Corporation, right? So that's why the manufacturer's designation SCRNE is there for this 555 timer, right? So like that, it was first introduced by Cynetics Corporation, and SC 555 or NE 555 is the name given to this, you know, manufacturer's designation letters, you know, for each type of manufacturer. Then Motorola MC, what is that, Fairchild, MUA, like that. Okay, all others I think you have in your notebook, and you also have their designations in your memory, right? And if you observe these other features of this 555 timer IC, it is a combination of digital and analog circuits, right? It is a combination of both digital and analog circuits. That means the internal circuit diagram for this 555 timer has both analog circuits and also digital circuits, right? Digital circuits like flip-flops, and analog circuits like comparators are there. Comparator, inverter are used, and digital circuits like flip-flop are used in this 555 timer. Okay, so it is a combination of both the digital and analog circuits. And if we come to the package type, right, each IC is available in different package types. So it is available in two package types, one in metal can type and also in dual inline package type. So when it is available as 8-pin dual inline package, we say it is mini DIP, and if it is more than that, we say DIP. So it is available as mini dual inline package type 8-pin IC, and it is also available as dual inline package IC with the 14 pins. Okay, that means it is available in dual inline package, and also it is available in metal can, or what we say round metal can package, right? We know how this metal can package looks. We have seen at the introduction of this chapter, this subject. Okay, so in the beginning we have seen what are the various packages, IC packages. Then the 556, okay, 556 IC contains two 555 timers. That means when we talk about a 555 timer, we also should mention what is this 556. 556 is a combination of. Then if we observe some other features, right? It is a timer. I think in your setting time, I think you might be using some alarm, some timer. Alarm is different and timer is different. Okay, so when the timer starts counting down or count up, whatever it is, countdown timer or count up timer, anything you can set. Okay, so whether you can go from what is that, 0 to low value to high value, 0 to 1000 you can count, or 1000 to 0 you can count down, count up or count down, anything you can do, right? This 555 timer, it can provide a time delay from microseconds to few hours, right? It can provide delay. That means, if you observe traffic lights, you will be there are different roads, and this is the 4-road junction, and here you have traffic light posts, and traffic lights will be indicated here. Okay. So now, how for some time red color light will be in on condition. That time all traffic will be stopped here, right? All the vehicles will be stopping. When it turns to green color, then they will be moving to the required direction. They will be moving in the required direction. So how long this red light will be in on condition, and how long the green light will be in on condition, all that it is set. Okay, so it is set by your 555 timer. Of course, nowadays we are getting other circuits also, right? Some more smarter circuits we are using, right? And this 555 timer you can set, for example, if you want to make this red light on for 1 minute, then your countdown starts from 59 to 0, right? 59 to 0, 59, then 58, 57, like that. It goes up to 0. So when this count is over, then red light will be off and green light will be on. So like that, to control this traffic, these traffic lights are used, and these traffic lights, how long they will be in on condition, how long they will be in off condition, all that is dictated by your timer circuit inside. So this uses your 555 timer, this 555 timer. So that means you can provide how much delay. Okay, we don't want 1 minute, means it is too high in busy hours, therefore let us make only 30 seconds, half of the minute. Then you can change that count. Sometimes some heavy traffic areas, sometimes they take 90 seconds also, 1.5 minutes also they will take. So depending on the requirement, the timer can be designed to set the timing. Okay, so like that, this timer, this 555 timer, it can provide a time delay from microseconds to hours. You can set microseconds time, you can set hours together, right? So sometimes if you design some circuits, they will go up to few days also. It can provide that much delay. It can provide that much delay, right? So then if you observe the supply voltage range, the supply voltage can be applied to this 555 timer from 5 volts to 18 volts. Depending on your requirement, we can give supply voltages from 5 volts to 18 volts positive voltage, right? So this is what about these are some features of 555 timer, right? So these are some of the features of 555 timer. It was first introduced by Scientix Corporation. So SC 555 or NE 555 is a and it is a versatile IC. It is available in different packages like metal can and dual inline package, and even in dual inline package it is available as 8-pin IC and also 14-pin IC, right? It can provide a time delay of a few microseconds to a few hours, and it may count to few days also sometimes. And the supply voltage that is required for this IC is from plus 5 volts to some up to 18 volts, up to 18 volts. Okay, then let us see the applications of 555 timer, right? So applications of 555 timer, it can be used as an oscillator, right? So some we see voltage control oscillator or oscillator, it can be used as oscillator, and it can be used to generate a ramp wave or square wave, right? So ramp and square wave generator, that means when we get a ramp voltage, ramp up, ramp down, right? Ramp up, ramp down. So ramp or sawtooth wave also we say, right? Ramp generator and square wave generator. Square wave generation already we know, we have studied using 741. Okay. Similarly, that means when it is used in a stable or monostable multi, we can have symmetric square wave or different time periods, all that. We have some knowledge on square wave generators also. A square wave generator using op amp we have seen, you can use same 555 timer for this square wave generator. Okay, so olden days 555 was there, later 741 has come. So anything can be used. Nowadays all smart sensors we are using, and we are using next generation square wave generators also. Okay, then frequency dividers, and then monostable multivibrator. You know what is a monostable multi? We have studied earlier. So monostable, mono one, right? So one stable state it has, and then burglar alarm, and then traffic light control, which I have mentioned, right? So like that, so many circuits, so many applications you can use this 555 timer, or you can design so many circuits. Okay, then what is that? Pulse generator and LED flashers. Pulse generator means, of course, it is also the short pulse. Of course, in detail, the applications of IC we will study. IC 555 timer we will study when it is connected, when it is used as multivibrator, monostable multi, what are its applications? When it is used as a stable multivibrator, what are the various applications? Okay, so only this class we study about the features and a functional diagram of 555 timer, and in the next class we shall study about monostable multivibrator, and that means 555 timer used as monostable multivibrator and its applications, and later 555 timer used as a stable multivibrator connected in a stable multi mode, and its applications we will study, right? And then if you see these LED flashes, right? You know, LED lights, what is that? Some decoration lights we see now. That means if you see Times Hospital or Ramesh Hospital, there will be some light. Otherwise, if you see Chandana Brothers or Tipsy Topsy, otherwise Kalyan Jewelers or Lalita Jewelers, all that. Okay, their name display will be there. That display board, it will be having some circuitry, right? So what is that circuitry? For some time, the lights will be, even when you travel in a bus, right? And if you travel by train nowadays, I think trains are not all the trains are running, but there are few trains, right? What is that? Pinakni Express, or this side, what is that? Vizag, Ratnachal Express, right? When you travel in an AC coach, there will be a display here, and in that display, how many kilometers you are away from the previous station, and how many kilometers you have to take travel to reach the next station. All that display will be available, right? So of course, LCD displays are used, and sometimes the LED displays both are there, right? And mostly these train displays are the project given to our electronics company, which we have in Vijayawada, right? They display all displays which are LED, LCD displays or LED displays that are related to railways. They are the ones who are manufacturing all the displays. Okay. So now, if you see these LED flashes, if you see some displays in front of some showrooms, okay, they will be on for some time. LED, it will be off for some more time. So how, when the otherwise one color will be in on condition, and after that another color will be in on condition. So how is it possible? Means there will be a timer circuit and it will be providing some delay. So for few seconds, red light will be glowing. For few seconds, what is that? Yellow color will be glowing, and for few more seconds, green color will be glowing. After that, so like that, delay will be calculated. I think we have done. I think you will be studying your microprocessor subject in next semester. That time you will be doing these experiments also, I hope, right? So this is what about some introduction to 555 timer, 555 timer features and applications of 555 timer, right? Then let us see the pin diagram of 555 timer. It is also just the most popularly we use 8-pin IC, 555 timer with the 8-pin IC. So 8-pin with the 8 pins, you can see this pin diagram like our 741. So 741 pins and their terminology is different. And here 555 timer pins and their terminology is different. Okay. So of course there will be ground and VCC common, but other terms are different. So you please learn this 555 timer IC. I think you are going to do these experiments in your LECA lab, I think. Okay. So now, if you see this point, this dot indicates pin number 1. So pin number 1 is ground. Pin number 2 is trigger input. That means we give externally. And pin number 3, it is output. Output of this IC is taken. This circuit is taken from pin number 3. And pin number 4 is reset. Pin number 4 is reset. And then pin number 5 is control voltage, right? If you want to have, if you want to apply some control voltage, you have to give here. So we will understand about all these terms when we see the functional diagram of this IC, which we are going to see now itself, right? Now itself, we are going to study the functional diagram of this 555 timer. Pin number 6 is a threshold, and pin number 7 discharge. That means if you connect charge and discharge, these terms are applicable to a capacitor. So if you provide, if you connect any capacitor here, this provides discharge path, and then the power supply VCC, right? So VCC, how much voltage we can apply to this 555 timer? I have mentioned in the previous slide. So how much, what is the voltage range for 555 timer? You respond in chat box so that my teaching will not be monotonous. It will be interactive teaching, right? So I told you already. So this 555 timer, it operates with certain input voltage or supply voltage range from 5 volts to 18 volts. Very good, very good. Nirmal Roy and Bindu Sri, it is correct, right? Always same students are giving, of course, Geeta, last name is Priya, right? So you please pardon me. Geeta, your name is visible as Geeta here. Last name, last part of your name, we are getting as some Priya or something. So please pardon me for not calling you properly, right? So Geeta, then what is that? Chaturya, very good. Priyanka, right? Geeta, something, all that, after that Priyanka. Good. Okay, so I'm very happy. All your names are very much familiar to me because you people are the ones making Tejaswini right. My name is Geeta only. Good, good, right? So Geeta, very good. I'm happy. From the beginning, I am struggling to call you. Whether I have to call you by Priyanka or Geeta. Good. Okay. So like that, we can say this pin, 8th pin, we can apply some power supply voltage. This power supply voltage, yes, many other friends are also responding. I'm happy. So let me move forward. Later I will see. Okay. So 8th pin, you can apply some plus 5 volts to plus 18 volts, right? Then this is what about the pin diagram, right? And now let us see the functional diagram of the 555 timer, right? So when I am explaining about this diagram, you will understand its meaning. Once if you understand the meaning for this diagram, you feel that it is a very simple diagram, right? But immediately when you see at a glance, right? At a glance, if you see somebody is taking snapshot, I think, still you please write, morning I have taken class and I thought of asking C-section people to share this diagram after drawing in their notebook. Right, I forgot. Okay, at least you people, you please draw this diagram in your notebook. At the end of the class, you please share this diagram in the chat box so that I will have confidence that you people are drawing the given circuit diagram. Why I am making you to draw this diagram is, unless you understand this functional diagram, you cannot follow the next explanation. That means next circuits applications, right? For example, if we say this is the functional diagram of 555 timer, right? Like doctor only. If you go to doctor, he knows where your heart is, where your lungs are, where your kidneys are, right? So they just see your pulse by touching your hand, but of course pulse runs throughout our body, right? Only near the hand they just observe, but if you go to doctor, they know where your heart is. Similarly, that's why if they want to perform some heart operation, what they do, near the heart only they will perform the operation. Similarly, here also, if you know what are the internal components, or what if you know the internal circuit, then only you can use this IC for several other applications. Okay, so therefore, if you learn this, this is suitable for monostable operation. This is that means the main functional diagram with slight modification. One component we connect here, that's all, right? One capacitor and one resistor we connect, and we connect it as monostable multivibrator. Okay, and with some more modification, we connect it as a stable multivibrator. So the basic functional diagram is same. Therefore, sometimes you are getting questions only on functional diagram, right? Therefore, whether they ask you or not, you draw the functional diagram and you explain, then you will get full marks in the examination, right? So sometimes they are asking separately, explain about the functional diagram of 555 timer. So it is very, very important, all of you. It is not sufficient if you take the snapshot. You please draw this diagram in your notebooks also, right? After the completion of drawing this diagram, you share in the chat box. I will observe later. But I know our regular principle, when I'm explaining, you will be listening with your ears and you will be drawing the same circuit diagram with your hands in your notebook. So parallelly, we are doing all that. So therefore, let me explain this functional diagram. Let me explain this functional diagram. See, at a stretch, if you see, it is looking like a very big circuit, but it is a very simplest circuit if you understand the meaning. So I will tell you how to understand this meaning and how to reproduce this in the examination or in your notebook. Okay, you just observe this. First, let me show you these dotted lines. So inside the dotted lines, that means the circuit internal diagram, right? So outside this dotted lines, only pins are available, right? So all these pins. Now you observe pin number 1. Pin number 1 is connected to ground. Pin number 1 is connected to ground. Then where is 2? Here. So 2 trigger, and pin number 3, it is here because it is taken as output. And pin number 4 is reset pin. And pin number 5 is control voltage. Here you can apply control voltage. Therefore, see, when we observe this input side, these are some pins, and output pin we have arranged this side. Okay. Pin number 5 control voltage, pin number 6 threshold voltage, and then pin number 7. Where is pin number 7? This is pin number 7, discharge, discharge pin, and then pin number 8 VCC, right? So power supply pin. So like that, these are the 8 pin. Now, if you observe from VCC to ground, 3 equal resistors are connected. Okay. So you just follow my cursor. From VCC to ground, 3 equal resistors are connected. So what are the values of resistors? 5K equal 5K, 5K. That means 3 5 kilo ohm resistors are connected one below the other between ground and VCC. So now what will happen when we have VCC and one resistor here, another resistor here, and another resistor here, right? This is all the resistors are of equal value, right? Resistor equal, all are of equal value, R, right? Then this is ground, this is ground, and this is VCC. Now, for example, if VCC is equal to 6 volts, for convenience sake, I am giving you a numerical example, right? Any voltage you can apply. So for convenience sake, I am saying VCC is equal to 6 volts. Then what will happen in this series circuit? Voltage will be dropped from ground to VCC. There will be 6 volts, but across this resistor 2 volts, and across this resistor 2 volts, and across this resistor 2 volts. 2 plus 2 plus 2, 6 volts. That means 6 volts is divided into 2, 2, and 2 volts because all the resistors are of equal value. If you do not want equal value, you can have respective value, right? So these 3 resistors, they provide voltage divider bias, right? So they provide voltage divider bias. Now you just observe, let me give you one question. From ground to this resistor, if I connect a voltmeter, how many volts I can measure? How many volts I can measure? 2 volts, right? So voltage drop across this resistor is 2. Now from ground to this resistor, if I connect a voltmeter from ground to after this resistor 2, how many volts I can get in my voltmeter or multimeter? How many volts I will get? You respond in chat box. Let me see, right? How many volts? Otherwise, you can unmute and respond. It saves our time. Otherwise, many of you are not able to unmute because of disturbance around you, and therefore you are typing, and you can respond. Let me see any response I got. Okay, from ground to, yes, very good, Nirmal Roy. It is 4 volts, right? That means only after one resistor, 2 volts, 2 resistors, 4 volts we will get. Exactly. Geeta also 4 volts, good, right? Many others also might be Satvika 4 volts, very good, right? Many of you are responding. Yes, your guess is correct. Now, if I connect this multimeter at this point, right after this resistor, I will get 6 volts. Otherwise, because I have mentioned it as 6 volts, you are giving me numerical values. Otherwise, if I don't mention these 6 volts, what we say, this is VCC applied. So what we say, here we will have 1/3 VCC, right? 1/3 VCC. And here we'll have 2/3 of VCC. 2/3 of VCC. And here complete VCC. 3/3 means 3 by 3, 1. So full VCC we will have. So 1/3 VCC across this resistor 1 VCC and full VCC here, right? So like that, you just observe this what potential voltage divider. This is resistor R1, right? 5 kilo ohms. And at this point across this resistor, we will have 1/3 VCC from ground to this resistor. And here we will have from ground to this, we will have 2/3 VCC, 2/3 of VCC. And therefore, you just observe this 2/3 VCC is given as reference voltage to, you can give either external control voltage, or from this potential divider, you can generate some reference voltage, and that you can apply to the op amp here. This op amp is connected as comparator, right? Op amp is used as comparator, right? So this is upper comparator and this is lower comparator. So here also one comparator and this is another comparator. So for these two comparators, we will have reference voltage. That reference voltage is generated by this voltage divider resistors. Right? This reference voltage is derived by these voltage divider resistors through VCC. That means from the same supply voltage, we are able to derive two different voltages. That is reference voltage to lower comparator and reference voltage to upper comparator. Okay. So this is what about a voltage divider. I have mentioned about upper comparator and a lower comparator. So what is a comparator? We know already. So it compares reference voltage with the input voltage, right? So depending on that, it will give its output either 0 or 1. And here also, it will compare and it will give a reference voltage with the applied voltage. It will give output voltage either 0 or 1. Okay. Now, if you observe, here we have a control flip-flop. So what is the function of this flip-flop? It is a control flip-flop, right? So we will see, first consider it as flip-flop. It is RS flip-flop, right? RS flip-flop, reset and set. So when reset equal to 1, that means when reset equal to 1, the output is reset to 0. Output is reset to 0. That means Q will be 0. When set equal to 1, flip-flop will be set to 1. That means Q will be 1. So depending on the outputs of upper comparator and lower comparator, the output of the control flip-flop will be changing. So this is what about a control flip-flop, right? So we'll see this transistor Q1 simply acts as a switch, and this is used as buffer. We'll come across these two transistors later. Now, if you observe the output of control flip-flop, Q bar is connected to the output through a power amplifier or an inverter, right? So let us consider it as an inverter. So what is the function of inverter? If you give input 1, it will give output 0. If you give input 0, it will give output 1. That's all, inverter. So these are the various circuits that we are using inside our 555 timer. So one inverter, one control flip-flop, and 2 comparators. One is named as upper comparator, other one is named as lower comparator, and 3 resistors which are named as voltage divider resistors. Okay? And 2 transistors. This is used as buffer and this is used as a switch. Now let us see the circuit operation. I think just now I have given what are the various components that are connected, that are used inside this 555 timer, right? Now, let us try to understand this functional block diagram of 555 timer, right? So what is the functional block diagram? Just now I have described description. I think I have written in the next slide also. So functional diagram description, just description. What is this? Voltage divider has 3 equal resistors and then 2 comparators are there. Circuit diagram description I am telling, right? So what all I have explained just now. It has 2 comparators and then of course it will be changing there. Then one flip-flop is used. So it will give either high value or low value and then transistor Q1 is used as a switch. So this is the description of functional diagram of 555 timer. Description of functional diagram of 555 timer. Right. Now let us see its working or its operation. Right. Just very simple, very simple. Okay, let us consider a standby mode. So what do you mean by standby mode? You will be keeping your laptop sometimes in standby mode. So what is this standby mode? That means a stable state. Okay. So that is, let us say that output is at 0. That means output. I am drawing here the output waveform. Right. So output is 0. Standby mode. So what is this? Output is 0 means what? Here Q bar is equal to 1. That means when in standby mode, Q bar is equal to 1. Q bar is equal to 1. When Q bar is equal to 1, you just observe this is 1, therefore output will be 0. When Q bar is equal to 1, you see that 1 is applied here. Okay. So it is like this transistor will be like in on condition, right? Base voltage you are giving. Therefore, this transistor will be like a closed switch. So when this is like a closed switch, you just observe this Q bar, it is reaching this point. Okay. So just reaching, it is connected to this. For example, if any capacitor is connected here, because of this closed path, this will be discharging. Whenever Q bar is 1, it will be discharging. So when we use capacitor for monostable vibrator, that time we will see. Now, if you observe at the input, okay, that is here in standby mode, right? So how long it will be in standby mode? Let us see, right? Now, if you observe to these comparators, reference voltages are fixed. Okay, what is the reference voltage to lower comparator? 1/3 VCC. That means voltage drop across this resistor, it is 1/3 VCC. That is the reference voltage. Now, to the other input terminal of the comparator, we are giving some trigger pulse. We are giving some trigger pulse. So we are giving a negative going trigger pulse. You just observe negative going trigger pulse. Okay, it is input we are giving here, right? Negative going trigger pulse we are giving. Now, when the when this input voltage, that is when whatever trigger pulse you are giving, when this input voltage is greater than 1/3 VCC, that means reference voltage. When this input voltage is greater than reference voltage, then this output of the comparator will be set to 1. Output will be set to 1. So when this output is set to 1, what happens? This is S signal to the flip-flop. That means set value is given to a flip-flop. Therefore, the flip-flop is set to 1. When flip-flop is set to 1, Q is equal to 1. When Q is equal to 1, Q bar will be 0. Q bar will be 0. Therefore, what happens when Q bar is equal to 0 and this is the inverter, this 0 will become 1 at the output of the inverter and output will become 1. Output will become 1. Right? So now, how long output will stay at 1? When does the output of the flip-flop changes? Let us see now. Right? So I think from this you understand when we give a trigger pulse at the input of the lower comparator, when the pulse is greater than the reference voltage, then lower comparator sets its output as 1. Right? So how long this will be 1? Let us see. Right? Now you come to this upper comparator. So what is the reference voltage to upper comparator? this reference voltage you can give from external source. Otherwise, here 2/3 VCC is applied. Okay, here you can see this dot mark, right? So here this is junction. 2/3 VCC is applied, and to the other terminal we have some threshold potential, right? So when this threshold potential is greater than this reference voltage, then this upper comparator sets its value 1, right? So when this upper comparator output is set to 1, that means reset is equal to 1. That means control flip-flop will be reset to 0. So when it is reset to 0, Q will be 0. When Q is 0, Q bar will be 1. So when Q bar is 1, output will be 0. So output will become 0, right? That means till this will be changing now. So this voltage will be changing. Okay. So that means when do we have this comparator transition and when do we have this comparator transition depends on your reference voltage and the input voltage that you are, trigger voltage that you are giving, Okay. So like that, the output of the 555 timer output here, which is available at pin 3. Now when it is 0, again same thing, right? So it will be changing. So when it is 0, what will happen? When this is 0, output will be at 0. Now when it is at 0 condition, this will be, when this is 0, it will be like open circuit. This Q1 will be like a switch, okay? Closed switch or open switch. So what I want to say here is the trigger voltage is changing from 0, otherwise negative going now. So let us say from some maximum value to 0, and then it is increasing and it is decreasing like that. Because it is varying, the voltage across these resistors are also will be changing. Okay, sorry, voltage across this resistor will be stable. The input voltage, that means voltage that is applied to the comparator, will be changing. So whenever the voltage applied to the comparator is changing, the output will be changing between 1 and 0, 1 and 0. Here also it will be changing between 1 and 0. And like that, this control flip-flop will be giving its output 1 and 0. Similarly, at the output of the 555 timer, we will get a 1 and 0. Finally, output will be either 1 or 0, 1 or 0. Like that, we will have the output. Okay. So this is what about the functional diagram of 555 timer. Okay. Once again, I want to repeat the function of this 555 timer. Right. You just observe here. First, let us say Q bar is equal to high. So with that, we are starting. Q bar is equal to high. When Q bar is equal to high, let me take another color so that sorry, pink color. Which color is better? I think the blue color is visible. Okay. Now let us say that Q bar is high. When Q bar is high, this inverter output voltage will be, here it is high, inverter output voltage will be 0. Therefore, I can draw output voltage as 0, right? That is okay. Now, in standby mode, now when you apply some input voltage at the trigger input, that means at the trigger pin. That means what type of input voltage you are giving? Some negative going pulse, right? That means some maximum value going to 0 and again going to maximum value, going to 0, like that. So a negative going trigger pulse we are applying at pin number 2, right? So now if you observe DC level DC level at the lower comparator, it is at 1/3 VCC. That means VCC by 3 or 1/3 of VCC, right? Now, what happens when this input voltage that you are giving at other input terminal, trigger terminal, is greater than this reference voltage? This comparator will give output 1. Comparator will give output 1. So when this is 1, this 1 is nothing but the set signal. Therefore, when set signal is equal to 1, flip-flop will be set to 1. That means flip-flop is set to 1 means what? Q is equal to 1. When Q is 1, Q bar is equal to 0. Q bar is equal to 0. When Q bar is equal to 0, to your inverter, you are giving this Q bar, and output will be, when it is 0, output will be 1. Therefore, output will be changing from 0 to 1. When this comparator output goes high. When does this comparator output goes high? When the input voltage or trigger voltage applied to the lower comparator is greater than the reference voltage, then output goes high, right? So like that, we get output is 0 initially, then it goes high, and it will be there for certain time. How long it will be there? How long it will be there? If you see, Q is equal to 1 and Q bar is equal to 0, right? Then during it is you just observe this comparators. Comparator. This is reference voltage is given at a non-inverting input terminal, and input voltage or trigger pulse is given at inverting input terminal, right? And if you see here, input voltage is given at non-inverting input terminal, threshold voltage, and reference voltage is given at inverting input terminal, inverting input terminal. Therefore, during positive excursion, that means when the signal is going positive, right? When the threshold voltage at pin 6, threshold voltage at pin 6 goes beyond 2/3 of VCC. That means you just observe reference voltage applied at this upper comparator is 2/3 VCC from this voltage divider. So when this threshold voltage, exceeds this 2/3 VCC, then exceeds, that means when this voltage, input voltage exceeds this 2/3 VCC, then this upper comparator will be giving its value 1, right? So what is this 1? It is nothing but reset signal 1. So when this reset signal is 1, flip-flop is reset to 0. So when flip-flop is reset to 0 means what? Q is 0. Q is 0. When Q is 0, Q bar is 1. So that 1 is applied here, and 1, and it is 0. It is 0. So now Q bar, right? So that means when the input voltage is varying from positive to negative, negative to positive, like that, then the outputs of the comparators will be changing. So sometime it is greater than 1/3 VCC, therefore it will be set to 1, and it will be remaining like that. But after during these variations, okay, so the threshold voltage at pin 6 will be greater than this 2/3 VCC, and it will be set to 1. So whenever this voltage set to 1, and it will be, output will be 0. So therefore Q bar will be 1, and like that, when Q bar is 1, output is 0. When Q bar is 0, output is 1. So like that, we get this type of output at the output of the 555 timer. Okay. So I think while explaining, oh, very good, ma. Some of you have shared your circuit diagram which you have drawn, and I think we have come to the end of the class. Let me take your attendance first, and then I'll stop for today. And once again, all of you read once again and try to understand and come for next class. I'll repeat once again this circuit. functional diagram. And when you understand this functional diagram, then only you can understand monostable and stable multivibrators. Okay, so I just stop recording.